Hello guys, so I would like us to look at some applications of integration with the first application being areas under and between curves. So given a sketch like this of a curve, and then you're being told to find the total shaded area. So the total shaded area is given by the integral. So we start here, the area E here, the integral from A to B of the curve here that encloses that area, which is f of x, minus the part f, since it is below the x-axis, that's why we are having the minus, integral from B to C, integral from B to C of the curve, of the curve f of x that encloses that shaded area, and then finally plus the integral from C to D of f of x that encloses that particular area. Now, if you're asked to determine the area between the curves y is equal to x cubed minus 2x squared minus 8x and the y-axis. So it's important for us to have a rough sketch so that we're able to know the limits, or able to know the points of intersection, and able to also see if the curves are below or above the x-axis, so that we can be able to come up with the integral. So taking up this example, in order for us to find the point of intersection of these two curves, we are going to equate them. Now, the x-axis is basically the curve y is equal to 0, and this other curve is y is equal to x cubed minus 2x squared minus 8x. Equating these two curves, we will have x cubed minus 2x squared minus 8x is equal to 0. Now, x is common in all these terms, so factoring it out, we have 2x minus 8 is equal to 0. So this basically gives x is equal to 0 as one of the points of intersection, and then solving the quadratic equation to get the other values of x. So x will be equal to minus 2 plus minus the square root of minus 2 squared minus 4 times AC, which is 1 times minus 8. All this divided by 2 times a, which is 2 times 1. So the rest of the values of x will be equal to, so solving that, we will have the rest of the values of x being equal to, so this is minus 2, that will give 2, and then this side minus 2 squared, that is 4, minus will give positive, so 36, that will give 6. So x will be equal to 2 plus minus 6 over 2, and that gives the values of x as, so 2 plus, that is 4, and then the other value 2 minus 6, that is minus 4 divided by 2 minus 2. So those are our points of intersection. Those are our points of intersection. So having known the points of intersection, so we can be able to have a rough sketch. So we have at x is equal to 0, replacing, so that we know the values of y's as well. So let's have a rough sketch of that. So, okay, so we have x is equal to 0 as one of the points of intersection. So this is our x-axis. Let's say our x is equal to 0 is at this point. Okay, so that's our point, x is equal to 0. Then we also have a point of intersection at x is equal to minus 2. So let's have it as minus 2. And we also have it at x is equal to 4. So let's have this point here as 4. So we already know that this curve passes through this point, and this point. So the next thing is to determine from this point to this point, is it like going this way or this way? Is it on the upper side or the lower side? And then from this point to this point, is it on the upper side or the lower side? So what we are going to do is I'm going to take a random value here. Like let's say I take 2, and here I will take minus 1, and find out that at minus 1, what's the value of y? What's the value of this curve? Now, value of x, then value of y. So when x is equal to -1, y will be equal to what? So we know y is equal to x cubed, so -1 cubed minus 2 into -1 squared, and then -8 into -1. And what will that give for our value of y? So -1 cubed, that's -1, -1 squared, we have -2 there, minus plus 8. So 8 minus 3 will obviously give 5. So 5 is obviously on the upper part of y. So this curve will obviously be going that way. Okay, fine. From 0 to 4, we want to establish if the curve is on the upper side or the lower side. So let's see. Taking 2, what are we going to have? So for our value of x, so for our value of x is equal to 2, what's going to be the value of y? So let's get y. So y will be equal to 2 cubed minus 2 into 2 squared minus 8 into 2. We've just replaced it in the equation of the curve, this particular curve here. Okay, fine. So evaluating that, what are we going to get? So 2 cubed. So 2 cubed gives us 8. 8 minus 2 squared is 4. This gives 8 as well. And then this gives minus 16. So 8 minus 8 is 0. And then this is minus 16. So minus 16 will obviously be on the lower side. So this one will be going this way. So we already have a rough sketch of how the curve looks like. So now the next thing is to come up with the integral that defines the total area. So how are we going to get the total area? So the total area will be given by, now look at the shaded area. The limits are from -2 to 0. So it will be given by integral from -2 to 0 of what is the value of the curve. The curve is y is equal to x cubed minus the curve that encloses it. So it's x cubed minus 2x squared minus 2x squared minus 8x. Okay, fine. So integral from -2 to 0 of x cubed minus 2x squared minus 8x dx. Okay, minus, since this part is on the lower side of the x-axis, so it will be minus integral from, what are the limits? This is from 0 to 4. 0 to 4 of the curve, which is x cubed minus 2x squared minus 8x dx. Then we just go ahead and evaluate that integral. So integrating that, what do we get? We integrate and replace the ranges. So integrating this, we will have x raised to power 4 over 4 minus 2 over 3 x cubed minus 8 over 2 x squared, and this minus 2 to 0 minus, integrating this other side, we have x raised to power 4 over 4 minus 2 over 3 x cubed minus 8 over 2 x squared, integral from 0 to 4. Then we evaluate that and get our answer. Evaluating that correctly, we should be able to get that this is equal to 49 1/3 square units, because we are looking for areas. So areas is basically units squared. Okay, fine, guys. So let's take up another example. So example number 2. Let's say you're told determine the area enclosed by the curves. So determine area and enclosed by the curves. The curves are curve y is equal to, so curve y is equal to x squared plus 1, and the other curve is y is equal to 7 minus x. So we've said the first thing is for us to really get to have a rough sketch of this curve so that you can be able to know how exactly it looks like. So the first thing we're going to do here is equate these two curves so that you can be able to know their points of intersection. So I will have x squared plus 1 is equal to 7 minus x. Then I will solve this so that we can be able to know at what point these curves intersect. Okay, fine. So this is the same as having x squared. If you bring x to this other side, it will be plus x. If you bring 7 to this other side, it will be 1 minus 7. So that will be minus 6 is equal to 0. So solving this using the quadratic formula, x is equal to minus 1 plus minus the square root of 1 squared minus 4 times 1 times minus 6. All this divided by 2 times 1. And what does this give? This gives 1 plus minus the square root of, so this is 1 squared minus that will be plus. So 24, 25 will give 5. All this divided by 2. Okay, so what's the value of x? 1 plus 5, 6 divided by 2, 3. And the other value of x, 1 minus 5, minus 4 divided by 2, minus 2. So we already have the values of, we already have the points of intersection. Now, the other thing is, clearly, we will come and have like a rough sketch of these points here so that we know how exactly the curves look like. Now, this right here is equation of a straight line, as we can be able to see. So now, having a rough sketch, basically what we know so far are just the points of intersection. So we have x is equal to -2. So let's say this is our point 0 here. Then x is equal to -2 is one of the points of intersection, and x is equal to 3 is also one of the points of intersections of these two curves. Okay, fine. So now, now that we already know, I want to know that in between here, so how exactly does this curve go? So let's start with this curve, x squared plus 1. So for values of x, we want to know values of y, and y is x squared plus 1. So we already know that -2 and 3 are point of intersection. So I can take -2 at point -2. What's going to be the value of our y at that particular point? -2. So let's see. Okay, fine. So okay, just a minute, guys. I'm noticing something here. This is -1. So actually, this point is supposed to be -3 and +2, guys. So we'll have to just change the drawing a bit. So the points of intersection, we have -3 and +2. -3 and +2. Okay, fine. So at -3, where is this curve? At -3, what's going to be the value of y? The value of y is going to be -3 squared, which is 9. 9 plus 1 will give 10. Okay, fine. In between, I would like to know, like, is the curve going on the upper side, lower side? So I'll probably take up, let's say, -1. At -1, where is this particular curve? So at -1, -1 squared will be 1. 1 plus 1, we'll have it as 2. Okay, fine. And at 2, which is another point of intersection, at 2, replacing 2 here, 2 squared, 4, 4 plus 1, that will give us 5. So coming to do a rough sketch of that particular curve, at -3, we've said the point is going to be 10. So 10 is obviously like on the upper side. So let's assume that's our value of 10 right there. And then at -1, so at -1, the curve is going to be at 2. So it's going to come all the way to 2. So let's assume that's our 2. So it was here, and at -1, it is somewhere at 2. Okay, fine. And at point 2, where is it going to be on the y-axis? We can clearly see it's going to be 5. So let's say 5 is there. So at point 2, it will be at 5, somewhere around there. So I'm going to join this. So, okay, not a perfect curve really. Let me make it smoother. So I'm going to have this all the way to 5 there. Okay, this is the other point. Now, this particular straight line, how is it going to look like? So let me have X values and Y values of that particular straight line. So I want to know where it's going to be at -3, but we already know because they intersect, they meet at that particular point. So, and then I would also like to know where it's going to be, let's say -1. Let's also take 0, because at 2, we know that they already meet at that particular point. Okay, fine. So y is equal to 7 minus x at -3. At -3, so replace the value of x here, we'll have 7, so we'll have 10, obviously. So at -3, it will obviously be here. Okay, fine. And at 2, we obviously know that it will be at 5. If you replace at 2, it will be at 5. At 0, it will be at 7. And since we already know it's a straight line, so I'm just going to like have a straight line that is joining these 2 points. Remember, this is just a rough sketch. So basically, our curve is going to look something like this. So from here, we can be able to clearly see that it is on the upper side, and we can clearly be able to see the limits. Now, guys, this is what I want us to see. We want to look for the total area that is shaded. However, you can see from -3 to 3, we have this area and we also have this unshaded area. So how exactly are we going to go about this? So the best way to go about this is to find the area of the whole of this region, this unshaded part and the shaded part, and then subtract the area that is unshaded so that you're left with the shaded area. So this is what I need. Shaded area will be equal to, so I will be evaluating the area of the whole thing, which will be integral from -3 to 2 of what? This whole area here is enclosed by this particular curve here. So the curve is 7 minus x dx, minus I subtract the area of this unshaded part, which is integral from -3 to 2, and this unshaded part here is closed by this particular curve. And what is this curve? This is our curve x squared plus 1. X squared plus 1. So basically, that's how I am going to go about this. So let's integrate and find our answers. So integrating that, we have, so the integral of 7, we have 7x minus x squared over 2, and then range is from -3 to 2, minus the integral of x squared is x cubed over 3 plus x, and the range of this is from -3 to 2. If you replace this correctly, you should be able to get that the area is 25/6 square units. And that's it, guys.